Three reasons why new universe fail.
Hey everyone. Yes, good evening, Yashaswini. Okay. Is that chemistry class is not yet over? Okay. Done. Good evening, Yashaswini. Yes, everything is perfect from my end. Okay, guys. Hi, hello everyone. Raj, Devi, Bhuvan, Bhuvana, Sneha. Okay, how the days are going? Good evening, Nancy. Am I audible right for everyone who posted that once? Am I clearly audible right for everyone? Yes, that is great. Okay, done. Hey, what happened? Please do cross check it once. Do cross check it once. Okay, I hardly get 10 members. Okay, start. And basically, I will give us the main idea what we are going to discuss in today's class. Okay, we are dive into the capacitors. 4 days over. Yes, good evening, everyone. Okay, and then, okay, in this class we will discuss about the polar molecules because yesterday discussed about the non-polar molecules. So non-polar molecules. Today we are going to discuss about the polar molecules. Polar molecules क्या होता है? Chemistry में पता है. In details I will explain. And then dielectrics. Dielectrics क्या है? क्या इसका use है capacitor के अंदर? Okay. Then capacitance with parallel capacitor with dielectric slab. मीन्स ये डाइलेक्ट्रिक स्लैब को उसके अंदर डालने से कैपेसिटेंस का वैल्यू क्या होता है, पोटेंशियल का वैल्यू क्या होता है, what happens to the potential and everything we need to discuss. Okay, and then yes, okay, dielectric slab is okay in this is there. What if I'm going to place, oh yeah, okay, now cross check it. If my voice is perfect, right? Cross check. Lata, tell me in the chat box. Is now okay, right? Voice audible? No. अरे यार. I will do one thing. I will keep mobile phone outside. Guys, now cross check karo. Is it clear, right? My voice. Is that clear? Yes. Great. Okay. About just I'm explaining the things. Okay. Dielectric slab insert करते हैं कैपेसिटर के अंदर क्या होता है देखना है. And in case if I'm going to place on conducting slab instead of dielectric slab, what will be happen? Dielectric means yesterday only I told that it's an insulator, right? It's a basically insulator. Okay, conducting means it's a conducting one. Correct. Now we need to analyze these all the things. And lastly, today we are going to discuss good numericals. Okay, numericals will solve. Clear, right? This is all about today's agenda. I can hardly see 17 members. Yeah, chalo start karte hain. Then again with a recall. Yesterday we talked about the energy density. Correct now? Sorry, energy values for a combination of capacitors. Right? In combination of capacitor, if I'm going to connect the capacitors in a series, then what will be their energy value? Right? That is what very interesting fact. Then we got an energy equation. हमको पता था energy value था half q square by c. Right? If I'm connecting n number of capacitors, means energy, total energy of the system will become, u1 plus u2 plus u3 plus up to un. Means just we need to add everything. Okay, this is over. Next, if I'm going to connect the same capacitors in parallel combination, okay, that time kya kar sakte hai? That time also energy will be same itself. Total energy can be written as u1 plus u2 plus u3 plus up to un. Just scalar addition. Okay, this is done. And then later on we discussed about the loss of energy. Kya kiya tha maine idhar? You might be remember this story what I told. मेरे पास 2 capacitors था. ओके दोनों टर्मिनल का कैपेसिटर दे हैड अ डिफरेंट पोटेंशियल, दोनों कैपेसिटर्स का टर्मिनल क्या किया था मैंने, जोड़ दिया था मैंने, राइट कुछ काम तो नहीं था ना, इसलिए बाद में क्या हो गया, द पोटेंशियल विल बी स्टार्ट टू मूव फ्रॉम हायर पोटेंशियल रीजन टू लोअर पोटेंशियल, मींस करंट फ्लो होने को चांस मिला, फ्लो होने से स्टार्ट हो गया, बाद में दे विल कम टू इक्विपोटेंशियल वैल्यू। यस 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 हाँ no actually here which one having a high potential means मान लो V2 is a high potential, this one will do the work on the capacitor 1, इसके ऊपर वर्क करता है, स्टोर करना है मींस वर्क करना पड़ता है, ओके विदाउट वर्क वी कांट से, ओके एंड देन कॉमन पोटेंशियल के लिए इक्वेशन भी मिल गया था हमको, डोंट फॉरगेट दिस वन कॉमन पोटेंशियल C1 V1 प्लस C2 V2 डिवाइडेड बाय C1 plus C2. Okay, when common potential आ गया, but the energy value, okay, energy value depending upon the electric field now, and as well as the potential. If energy value decreases, means potential decreases, means energy value also decreases, right? Then what will be the loss of energy here decreases? We need to find out. That's why before sharing the charges, okay, when we connect this circuit, no, when we connect this circuit. ओके बिफोर शेयरिंग द चार्जेस हाउ मच एनर्जी था इसके अंदर, ये दोनों के अंदर, एंड एज वेल एज आफ्टर शेयरिंग द चार्ज कॉमन पोटेंशियल आ गया, उसके अंदर कितना चार्ज है, ये दोनों कॉन्सेप्ट मिलाकर वी डिराइव दिस इक्वेशन करना, लॉस इन एनर्जी वैल्यू C1 C2 डिवाइडेड बाय 2 C1 plus C2 V1 minus V2 whole square, right? This is the equation we done in yesterday class, and then based on this one we solved few good numericals also. And later on polar molecules एक concept मैंने ले लिया था. Actually why I took this polar molecule concept, no, actually in chemistry it will become, but polar molecules non-polar molecules we need to study about to know the dielectrics. polar molecules क्या होता है actually आपको पता है in chemistry, basically in chemistry I'm saying, okay, positive centers and negative center of the क्या है इधर देखो, negative center of the charges will not coincide, correct na? देखो the molecule which has center of positive charges and do not coincide with the negative charge, they actually make a dipole momentum है उसके साथ, dipole momentum means दो charges should be separate with some small distance, वो उसको कहते हैं हम polar molecules, and most probably the polar molecules does not have a symmetrical shape, a symmetrical shape नहीं होता है in our system. If I'm going to considering this is a system, okay, this one middle one if I'm going to take as a system means इसके अंदर जो molecules है ना वो randomly arrangement होता है, right? Even they're possessing a single molecule possessing the net electric field, net dipole momentum means if we are going to consider whole things, the net electric field inside will be zero, and it possessing the dipole momentum value also zero just because of their random direction. देखो इधर in the absence of electric field the permanent dipole momentum of a molecules or in random direction, and hence the net dipole momentum value will be zero, p value 0, e value 0. Okay, if I given a electric field in this direction I applied the electric field, what happened at this time on this charges, guys you know right, charge के ऊपर force लगता है, पता है ना, टेल मी इन अ चैट बॉक्स, चार्ज के ऊपर फोर्स लगता है, पॉजिटिव चार्ज नेगेटिव चार्ज है मींस इलेक्ट्रिक फोर्स बारे में बोल रहा हूं मैंने, ओके इफ द इलेक्ट्रिक फोर्स इज एक्टिंग इन राइटवर्ड डायरेक्शन, मुझे ये बोल दो राइटवर्ड डायरेक्शन में क्या है, इलेक्ट्रिक फील्ड है, इधर राइटवर्ड डायरेक्शन में इलेक्ट्रिक फील्ड है. नाउ टेल मी ऑन पॉजिटिव चार्ज फोर्स ऑन विच डायरेक्शन इट इज एक्टिंग, in which direction the force will be acted on the positive charge, towards right or towards left? This is a question which I posed to you all. Okay, I got one response. Rajat, पॉजिटिव चार्ज के ऊपर बोल रहा हूं मैंने, इलेक्ट्रिक फील्ड एंड फोर्स के लिए एक इक्वेशन था, इलेक्ट्रिक फील्ड इंटेंसिटी इज इक्वल टू फोर्स बाय चार्ज, करेक्ट ना? उधर मैंने बोला था इफ इट इज पॉजिटिव चार्ज the force will be acting on a particle, positive charge particle, in a same direction. Okay, इसके ऊपर force यही direction के ऊपर act करता है. If it is negative charge means electric field is in this direction, but force will be acting opposite direction. Charge के लिए, negative charge के लिए, correct ना? Cool, cool. कोई problem नहीं, कोई problem नहीं. Okay. Okay, if you have a doubt means please reach out me. I will explain once more. कोई problem नहीं. Clear, right? The concept. Now देखो इधर. Now if I'm going to apply the force on this tab here, okay, then positive charge, all the positive charge will be start to move in that direction of applied electric field. Okay, if I'm applying the zoom this one, guys, in your mobile, zoom this figure what I'm writing on here. Now I'm going to apply the force on here means all the positive charges will be orient in this direction. Like negative charge will be moving in this direction, right? Again, they are making the dipole momentum, but the net dipole momentum ka direction will align to the one direction. Dekho, one direction they will get aligned. Yes, exactly. They will get aligned in one direction. Correct na? At this time, not completely it will align. Okay, in actually non-polar molecules, okay, thoda align hota hai, right? This like property we called as an polar molecules. Examples aapko chahiye means take this three are an examples. Okay, HCl, H2O, NH3, CO2, etc. Done? Clear, right? This concept polar molecules ke bare mein. Is that clear? Polar molecules. Shall we begin non-polar molecule? Good. Okay, let us go one by one line. Okay, theory है ना? अच्छा है. Non-polar molecule which has center of positive charges coincide with the center of negative charge. Means इधर positive charge, negative charge दोनों क्या हो गया है? एक ही तरफ coincide हो गया है. They are not at, actually they are not at separated with some distance. A distance nahi hua hai. They are actually overlapped each other. Okay, like those molecules we tell non-polar molecules. Okay, non-polar molecules के लिए example N2 means nitrogen है, CH4 oxygen, C6H6 benzene है. Okay, इधर देखो N2 while writing what you will write? N double bond N, right? You will write. Right, what I am saying? बोल दो ना चैट बॉक्स में. कोई नेगेटिव चार्ज भी नहीं है इधर. If it is there means both are will be same. In atomic structure the value triple, sir. Okay, triple triple bond. Okay, jai अर्थ आयतु. Okay, they are actually coincide here. O2 में also CH4 same and C6H6 benzene also. Okay, they are coincide each other. How it will be coincide? Let us go through the graphical representation. Then we will get to understand. मान लो this is N, this is N. Okay, ये दोनों N2 है. Okay, their centers देखो इधर. इसका center इधर ही है, इसका center इधर ही है. Means positive charges will be same at their centers. Negative charges will be present at one point. Right? Now, if I'm going to apply an external, इधर electric field value 0 होता है first of all, and then momentum also 0. This is in the presence of electric field 0. But if in case if I'm going to apply the electric field, देखो purely ऐसा था purely. This is center, positive charges. Okay, if I'm going to apply the external electric field, they will be orient like this. Right? Again देखो positive charge कुछ और है, negative charge will be और position में. And at this time dipole momentum will be, is there any dipole momentum is? Yes, we can say here. देखो, when electric field is applied, the positive charges are pushed in the direction of electric field, as I told you, and then electrons are pulled in the direction opposite to the electric field. Electric field के opposite direction, electric field negative charge को pull करते हैं electric field. And due to this separation of effective centers of positive and negative charge, dipole is formed. Okay, due to this one, dipole is formed here. Here we will get a permanent dipole momentum. किधर non-polar molecule में क्या होता है? We can say here permanent लिख दो इसको, परमानेंट डाइपोल momentum we will get. In which scenario? It is in a non-polar molecules. Clear? Let me know. Is that clear? Okay. Guys, do participate. I will take names also even. Abhi, Akila, Bharat, Chandana, Rajat, Raj, Prapti, Punima given reply. Okay, Akila, okay. Sneha, Swati, Swastik, kaha hai bro aap? Vanishri, Trishna, Ram. In initial classes you are giving response. What happened, bro? Are you understanding or not? Manthan, good. Okay, do participate in a chat box. Next thing is dielectrics. Yes, Swati, good. Okay, dielectrics सीखना भी बहुत important है. Now we know that dielectrics मैंने बोल दिया था, basically these are all the insulator मैंने बोल दिया था. Directly we can say these are the insulators. Generally non-conducting medium insulator are called as an dielectric. Okay, now precisely the non-conducting material which induces the charges are produced at their own phases. Application of electric field are called dielectrics. Means simple है. Actually dielectrics means they won't conduct. They won't conduct means मान लो this is a dielectric material. This is a dielectric material. It won't conduct the electricity, right? From end A to end B, it won't conduct electricity. I will write in a bigger form. देखो इधर. This is dielectric. From A to B, there is no conduction of electricity because it is an insulator. Okay, it is an insulator. But if I'm going to apply electric field, if I'm going to apply here means okay, क्या होता है इसके अंदर molecules होता है ना. No, only I told these are all the non-polar molecules, right? They will arrange like such a like that, guys. This is negative charge, this is positive. They are coincide means they will get arranged like this. Okay, sorry, this is positive, this is negative charge in a direction of electric field, right? They will arrange like this themselves. Align करता है उसके साथ साथ. At this time देखो इधर negative and positive की तरफ dipole momentum होता है. Dipole momentum हो रहा है means here it is creating some electric field. Correct what I'm saying? Now at this time without conducting some electric effect will be transferred from end A to end B. क्या transfer होता है? Electric effect. Shock होता है ना वैसे, right? Electric effect will be transferred from end A to end B, right? This is done by actually dielectrics. Clear? Idea clear हो गया ना? Dielectrics क्या करता है? Basically they are insulator. Basically they are insulators, but they will give the electric effect. Electric effect देते हैं. Cool. Okay, I will rub this one. Take a screenshot if you want means. Okay, 1, 2, 3, 4, done. हाँ bro, will do. अभी capacitors is the best example. That's why I told this one. Okay, देखो examples: air, hydrogen, glass, mica sheet, and as well as paraffin, wax. Wax it's an best dielectric material for us here. Okay, and then transformer oil. Oil क्या होता है ना? Transformer oil आपके TC बोलते हैं ना, in rural area now TC ಇಂದ call ಮಾಡ್ತೀವಲ್ವಾ ಮನೆಗೆ ಸಪ್ಲೈ ಮಾಡಕ್ಕೆ electricity. Okay, we need to fill that TC with oil. Some oil we need to fill. Okay, that oil also a dielectric. If it is electric means क्या होता था? Current will be shock and short circuit होता था, right now. But we are keeping the dielectrics inside the transformer. Why we need to keep that one? We'll study this one in a 7th chapter, right? Up to that we need to keep the calmness. Okay, let's study about the capacitor now. Polarization of dielectricity. Polarization क्या होता है? Guys देखो इधर. We know that dielectric के अंदर molecules का arrangement कैसा होता है. Just मान लो electric field value will be 0. This is the dielectric one. ओके एक ग्रीन कलर का है ना गाइस, देखो एक ग्रीन कलर का है ना ये स्लैब, इसको मैंने मान रहा हूं डाइइलेक्ट्रिक, ये सब्सटेंस है। ओके उसके अंदर कुछ भी नहीं है एंड वी आर नॉट एट अप्लाइड एनी इलेक्ट्रिक फील्ड ओवर हियर। ओके these are the two plates, this is plate A, this is plate B. I kept the dielectric substance, this is a slab, I will call this one as a slab. Okay the two dielectric wala. Okay and inside now positive center and negative centers are coincide themselves itself. Okay they are coincide here, hence there is no electricity will be passed from one end to another end. Done. And then later if I'm going to apply an electric field, apply an electric field, देखो कैसे चेंज होता है applied electric field. After then there is an orientation of positive and negative charge in an electric field, right? This कहानी मैंने explain किया था just half an hour back. क्या था? This is positive charge means इसको मैंने क्या करता हूँ, एक बैटरी को कनेक्ट करता हूँ, right? Then this plate will become positively charged one, this plate will become negatively charged one, down or plate B. But देखो this center of positive charges and center of negative charges they are actually inside. No, at this time electric field will be passing over here, the negative charge will be moving here, positive charge will be moving in the direction of electric field, hence they will create a permanent dipole momentum, they will create a permanent dipole momentum like this. When they are creating dipole momentum in this region आप देख सकते हैं करेक्ट ना, पॉजिटिव चार्जेस एंड नेगेटिव चार्जेस आर इक्वल होता है, किधर देखो इधर, इधर पॉजिटिव चार्ज है नेगेटिव चार्ज है, पॉजिटिव चार्ज नेगेटिव चार्ज, hence in this whole region if I'm going to consider in this whole region the value of electric field intensity or charge will be zero, न्यूट्रलाइज हो जाता है ये एरिया में, ये डॉटेड सर्कल का एरिया है ना इसके अंदर कंप्लीट वैल्यू ऑफ चार्ज विल बी जीरो, बट रिमेनिंग चार्ज विल बी वेयर इट विल बी रिसाइड. देखो इलेक्ट्रिक एक स्लैब है ना, स्लैब के इनर एज में चार्जेस लोकेट हो रहा है, इनर एज इधर माइनस चार्ज लोकेट हो रहा है, बट आउटर एज इन दिस वे ओके बी के पास है ना इधर पॉजिटिव चार्ज क्या हो रहा है, इंड्यूस हो रहा है, राइट? व्हाट आई एम सेइंग, आर यू गेटिंग राइट? लेट मी नो इन अ चैट बॉक्स. Are you getting right what I'm explaining? Yeah, paper also bro, paper also an example dielectric के लिए रिप्लाई करो. Did you got right what I'm explaining here? Dielectrics क्या होता है, उसके अंदर क्या हो रहा है इधर, is it understood or not? Yes, good. Honestly good. सो रहा है क्या, मलक बिट रहा है गुरो, ಚಾಕ್ಲೇಟ್ ಕೊಡಿಸ್ತೀನಿ ಇದೇ ಎಲ್ಲ ಬೇಗ. ಓಕೆ लुक at here, good guy. now next step देखो, now इसके अंदर भी ये this is negative charge here, this is positive charge, ये दोनों को वजह से electric field will be produced in this direction. इसके अंदर भी electric field produce हो रहा है, that one we called as an polarization here. इधर क्या हो गया, along the in the applied direction of electric field, due to application of electric field dielectric के अंदर positive charges negative charges are separated, positive charges and as well as the negative charges are separated. This process we called as an polarization. Polarization means to the applied electric field positive charge and negative charge should be separate with some distance. This is called polarization. स्ट्रेस करके बोल रहा हूं मैंने, right? And then we call this one as induced polarization also. We can call this one as here EP represent कर रहा है ना, EP stands for here induced polarization. उसका नेट पोलराइजेशन, नेट इलेक्ट्रिक फील्ड इंटेंसिटी क्या होता है ये दोनों के बीच में कैलकुलेट करना है, दैट इज वेरी इंपॉर्टेंट. देखो बिफोर दिस आर कैपेसिटर प्लेट्स, दो कैपेसिटर प्लेट्स है, इधर प्लस इधर माइनस है, ड्यू टू दिस टू चार्जेस इधर इलेक्ट्रिक फील्ड था, दे आर रिटन हियर E naught, I will write as it like that, E naught था. And when we are going to keep a dielectric material inside this one, okay, इसके अंदर ड्यू टू दिस इलेक्ट्रिक फील्ड क्या हो रहा है, अगेन हियर नेगेटिव, हियर पॉजिटिव, मींस इसके अंदर भी एक इलेक्ट्रिक फील्ड क्रिएट हो रहा है, करेक्ट ना? आई विल कॉल दिस वन ईपी. देन व्हाट विल बी द नेट इलेक्ट्रिक फील्ड दे आर आस्किंग. नेट इलेक्ट्रिक फील्ड क्या होता है? देखो, सम ऑफ दीस टू इलेक्ट्रिक फील्ड्स, E naught plus EP. But EP value, this EP value, induced electric field, is the opposite direction for the original electric field. That's why we need to keep here on negative sign. For this reason, electric field intensity value comes to be, देखो इधर E naught minus EP, means वो दोनों का difference आता है. Clear? Is that clear? Tell me, yaar, is it clear? Rajat, Swati, Purnima, Yashaswini. Yeah, I will explain. देखो, simple सा concept है ये भी. These are the two plates. Okay, these are the two plates. Okay, ये दोनों प्लेट के ऊपर चार्ज है, इसलिए इलेक्ट्रिक फील्ड क्रिएट हो गया E naught. It's an original electric field. If I'm placing any another slab in between these two, okay, it is a dielectric, means इसके अंदर भी एक induced polarization होता है due to the external electric field. Okay, that time total electric field calculate करना है, means we need to add these two, E naught plus EP, but EP is in opposite direction for the E naught, right? That's why the value will become E naught minus EP. Clear? Now tell me, is that clear? Yes, good. And then this is the value of K. K value पूछ रहे थे ना आप, we discuss this value, K is equal to 1 by 4 pi epsilon naught. कैसे आ गया, right? This came from this field only. Okay, here K value we can written as, guys, actually original electric field था कुछ इन दोनों प्लेट के ऊपर, ये दोनों प्लेट के ऊपर कुछ बीच में थोड़ा इलेक्ट्रिक फील्ड था. Okay, when I am introducing some medium, okay, this is some medium, right? Extra medium, right? At this time इलेक्ट्रिक फील्ड का इंटेंसिटी का वैल्यू क्या हो गया? डिक्रीज होता है क्या, इंक्रीज होता है क्या? बोलो. Now tell me, when I'm introducing dielectric material inside it, electric field, whether it is decreasing or increasing? I got one response. I'm expecting this one from everyone. Okay, इलेक्ट्रिक फील्ड वैल्यू क्या होता है? ओरिजिनल था ये, ओके, ये दोनों के बीच में और एक इलेक्ट्रिक फील्ड आ गए अपोजिट डायरेक्शन में, कुछ कम होना चाहिए, करेक्ट ना? मींस डिक्रीज होता है, मींस इट्स अ रेशियो ऑफ ओरिजिनल इलेक्ट्रिक फील्ड टू नेट इलेक्ट्रिक फील्ड. हाउ मच डिक्रीज हो गया है, करेक्ट ना? E naught minus EP. Okay, this value will gives the value of dielectric constant K. Is that clear? लिख दो इसको, it is very important. Is it clear? Okay, we'll move on to the next concept. Okay, done. देखो इधर डाइलेक्ट्रिक स्ट्रेंथ है नेक्स्ट कॉन्सेप्ट हमारा. ओके, डाइलेक्ट्रिक स्ट्रेंथ क्या होता है? Anyone, if I'm going to take human also, okay, you people also having some strength. मान लो this is you, okay, आपका कुछ strength है, okay, क्या है आपके पास? कुछ strength है. What I will do, I will kept on your head around 20 kg weight. Okay, you will sustain with the 20 kg. I will put again 20 kg. Okay, that one also you will sustain. If I kept another 120 kg, that time you will feel like थोड़ा stress होता है. Further, if I kept 20 kg extra more, means at this time what will be happen? You will definitely break down your strength. Correct ना? Bye, मुझे नहीं होता है, छोड़ दो मुझे. Right? You will say like that. Fell down, definitely. Fell down is nothing but your strength will be break down that time. In a similar way, we need to talk about the dielectric strength का breakdown क्या होता है. Means मान लो this is the two plates which we are considering. That is a beautiful place, that is a capacitor. They are separated by a distance d, positive charge, negative charge. ये दोनों के बीच में क्या रखा था हम? अब बोलो क्या रखा था, इसको क्या बोलते हैं? क्या बोलते हैं इसको? व्हाट विल से फॉर दिस वन? डाइलेक्ट्रिक, करेक्ट ना? डाइलेक्ट्रिक। ओके, इसका भी एक स्ट्रेंथ होता है। ओके, इसका भी एक स्ट्रेंथ होता है, राइट? वो स्ट्रेंथ मैक्सिमम तक विथस्टैंड करता है ना, उसको हम बोलते हैं डाइलेक्ट्रिक स्ट्रेंथ। मींस मान लो इसका इलेक्ट्रिक फील्ड का वैल्यू था 300 वोल्ट पर मीटर। ओके, अप टू दैट पॉइंट इट विल बी सस्टेन, मान लो, just like that, won't be like that. Okay, now if I'm giving more than that 300 volt per meter, what happens? This dielectric medium will sustain, it won't sustain that electric field, it will be breakdown, it won't work that time. That it will not break, means physically it won't break down, physically it won't break down, material will won't break down, but the working function will stop. Yes, exactly. Clear? Am I reaching everyone, right? Let me know in a chat box. Concepts, everything is clearing. सब कुछ reach हो रहा है ना सबको? I need an answer from each and everyone. Okay. Yes, Akila, you're right. Right. Yes, Sachin. Good. Right. Okay, I told you no dielectric strength है ना. I say कुछ material मैंने list out किया है. Okay, इसका dielectric strength कितना होता है? मैं मान लो vacuum है. Vacuum, nothing is there. You're starting conducting with me. Thanks, bro. Anyways, okay, a vacuum है ना, उसका dielectric value will be infinity. Infinite तक, if you're applying infinite number of infinity value of electric field also, it won't break down. And when we come across the air का dielectric value होता है, strength होता है 0.8 to 1 kilovolt per millimeter. Okay, and then for a porcelain dishes, you know, right? In our home appliances we are using, or else in our laboratory we are using the porcelain dishes, especially in chemistry, to heat the substance we are using the porcelain dishes. That's value will be 4 to 8. And then pyrex, I don't know this one exactly. Paper, already someone took paper, right? Gayan, I think, or Manthan, right? Paper का dielectric strength होता है 14 to 16. And then for a rubber it will be 21. Mica sheet, it has a dielectric strength around 160 to 200 kilowatt or kilovolt per millimeter. No, Gayan, it won't conduct. Okay, why should it has to conduct? There is nothing in between our two capacitor plates. If we have a okay, I will tell you one more interesting point here. Thank you for reaching me here. मान लो, this is capacitor plate. Excellent question, bro. Excellent question. Okay, this is a capacitor plate. Okay, ये दोनों का बीच में कुछ potential है V, मान लो. Okay, now electric field था ये. Now this is the substance which I'm keeping here. There's a dielectric medium. If the dielectric medium is not working, means physically it is not working, means external electric field का strength इसके ऊपर ज़्यादा है, तुम्हें जास्ती है. However, at this time it won't work. Original electric field, whatever it has no priorly, the same electric field effect will be taking place. That's it. And moreover, if I am connecting these two capacitor plates with a wire, मान लो wire से connect किया मैंने, do you know what will be happen? Is there any idea? Let me know. If I connect these two capacitor plates with a wire, what happens? For example, change in future substance before after breakdown of the electricity. Abhi, I didn't get your question, bro. Could you please pass again once? कोई problem नहीं. Okay. I want this answer, guys. What happen if I charged capacitor को connect कर दिया मैंने with a some wire? what happens there next? Note on this question. At any cost, no, at any cost try to find out this question in a tomorrow class. Okay, definitely I will ask this question tomorrow. Okay, now we'll dive into the capacitance with a parallel plate capacitor with a dielectric slab, short circuited. Hey, great. Yes, exactly. Okay, शॉर्ट सर्क्यूट होता है, उसके बाद क्या क्या हो सकता है, just collect some information. Okay, we'll jump into the पैरेलल प्लेट कैपेसिटर. मेरे पास पैरेलल प्लेट होता है, उसके बीच में in between these two parallel plates I will keep on dielectric medium over here, and then what will be the capacitance we need to calculate. Let's go one by one. Okay, क्या होता है, मान लो this is the two parallel plates which I connected. These are already having a charge distribution over here, means they had a net electric field intensity E naught. Now if I'm going to insert any dielectric substance between these two parallel plates, okay, dielectric के अंदर क्या होता है, एक phenomena होता है, मैंने बोल दिया था, polarization बोल दिया था. So what will be happen if the strength of dielectric breakdown? Nothing happen. Okay, strength of dielectric will be breakdown, means the capacitor, whatever the it has an initial value of electric field, no, the same electric field will be remains. It won't work. That's it. It won't work. Clear now? Yes, polarization takes place. If polarization will be takes place, means guys, inside the dielectric slab, okay, some amount of electric field also created. Some amount of electric field also created. Hence, the net electric field लिखना है हमको, means we will write the net electric field in this format. E naught is the original electric field. EP is the polarized electric field. Polarized electric field, or we can say that one in terms of induced electric field also. मान लो ये दोनों प्लेट है ना, ये B, ये इसका बीच में डिस्टेंस है D. Okay, and whatever the slab we are inserting in between the two plates, their thickness is T. Their thickness is T. Then they go one by one, we will calculate what will be the potential value in between these two. We need to calculate. Potential value के लिए formula था E into D, right? E into D था. I will agree with this one. Right now, right what I'm saying? Potential के लिए formula था E into D. But here something I written. देखो क्या होता है, इधर इलेक्ट्रिक फील्ड का वैल्यू दो चीजों का होता है, बिकॉज दिस कंडक्टिंग नॉन कंडक्टिंग स्लैब है ना, इसके अंदर भी इलेक्ट्रिक फील्ड है, इसका थिकनेस T है, बट दोनों प्लेट के बीच में भी कुछ इलेक्ट्रिक फील्ड है. दैट्स व्हाई वी नीड टू एक्सपैंड दिस वन. कैसे, देखो E नॉट इनटू ये दोनों बीच का डिस्टेंस है ना पैरेलल प्लेट का, नाउ इट वोंट बी D. ये थोड़ा T थिकनेस है ना, ये ऑलरेडी कुछ कहा गया है इधर. That's why we need to write here D minus T instead of that one. Plus second one, induced polarization. इसके अंदर भी induced polarization है, उसका वैल्यू EP into उसका थिकनेस कितना है, डिस्टेंस T है. Right what I'm saying? Right now means induced लिखना के वजह से we can write inside this value also we can write, means net electric field also it is enough. Net electric field due to this T thickness. Then this equation will come. I will call this equation number 1. Is it understood right how I took the values? Is it understood? इसके ऊपर प्रॉब्लम देता हूं मैंने आज. Okay, tomorrow at any cost you have to do this one and we'll solve from tomorrow onwards. If I teach this concept, no, there is no concept in a capacitor. We'll solve numericals. पूरा ये हफ्ता न्यूमेरिकल से जाता है. Good question will solve. Okay, done? Yes. देखो next we know that K value, correct ना, इसका डायरेक्ट स्ट्रेंथ होता है ना K value, we know that E naught by En, right? इधर En है ना, इसका वैल्यू क्या होता है, En value will be equals to, इधर इसको चेंज करो, E naught by K होता है, correct? Now substitute this value in this equation. Substitute करो. Substitute करने से हमको मिलता है, किधर हो गया, हाँ, V is equal to E naught, same D minus T as itself, plus इधर E naught En के प्लेस में E naught by k, E naught by k. ये थोड़ा अजीब लग रहा है, मैंने वॉश किया इसको. क्लियर ना? नेक्स्ट देखो क्या होता है नेक्स्ट स्टेप में. सेम है, E naught दोनों टर्म में कॉमन है. I will take common outside. If I take common outside means remaining term things will be here d minus t plus either t by k. T by k. We got the potential. Potential we got. Guys, देखो इधर potential how it is related with the k. Is it directly proportional or inversely proportional? Directly proportional or inversely proportional? Yes, keep this one in your mind. Okay, keep this in your mind. In the final thing, when we are concluding, no, I will explain what happens with the capacitance, what happens with the potential, what happens with the electric field intensity when we are going to keep one dielectric medium in between the two parallel plates. Right? Good. Good. Keep this one in your mind. And then, but we know that capacitance find out करना है and also electric field intensity है. ये दोनों प्लेट के बीच में इलेक्ट्रिक फील्ड इंटेंसिटी फाइंड आउट करने के लिए, दिस इज अ प्लेट 1, दिस इज अ प्लेट 2. वी नो दैट इन दिस रीजन 2 था. थिंक करो. ओके, इलेक्ट्रिक फील्ड इंटेंसिटी क्या आ गया था? सिग्मा बाय एप्सिलॉन नॉट आ गया था. राइट, व्हाट आई एम राइटिंग? सिग्मा बाय एप्सिलॉन नॉट. बट सिग्मा मींस इट इज नथिंग बट इट्स a charge density, surface charge density. Q by A we will write. If I'm going to replace this sigma, then we'll write Q by A epsilon naught. This is the electric field intensity हो गया, right? And then we know that one more point, क्या था? Capacitance. Capacitance के लिए equation था Q by V, correct ना? Q by V. We got to know that one point QV. Substitute that V here in this equation. I will call this equation number 2. Equation number 2 के अंदर ये V को substitute करो. Substituting that one, V will be comes to denominator, right? Then the value will be comes to be like this. You want means I will solve this one here. कोई problem तो नहीं है, simple सा है. ले पंगा, ले लो इधर. C is equal to Q by V, correct ना? Okay, Q as itself divided by V means इधर है A equation. E naught D minus T plus T by कुछ हो गया ना, C by Q by V, right? Q हो गया, K है, सब कुछ ठीक है ना? Yes, everything is perfect. And then E naught value also we got to know that Q by A epsilon naught. Substitute this value here. Then this value will be Q. However, it will be cancelled. देखो इधर Q divided by again Q divided by A epsilon naught into remaining thing will be here D minus T plus T by K. Correct ना? Q cancel. Denominator of the denominator. This term will be comes to numerator. Right now, if it is comes to numerator means here देखो A epsilon naught divided by D minus T plus T by K. This is guys actually the value of capacitance. The value of capacitance. Is it clear now? Tell me. Is that clear? Sir, you are looking like yaar. Gayan. Okay, good. Clear now? And now tell me guys, is this C value how it is related with this K? K के ऊपर कैसे relate कर सकते हैं? Directly or inversely? Equation देखो ध्यान से and tell me. Yes, because this is denominator. K is in denominator of the denominator. It will comes to numerator means it will be comes to numerator. Correct? It will be directly proportional. This is the second thing which I'm introducing here. Keep this point also in your mind. Okay, done. And C का value मत बोलो, A epsilon naught divided by D minus T plus T by K. Okay, this is very important when we are placing a dielectric slab. Clear है ना? ये सब छोड़ दो, it is enough. Okay, and we'll move on to the next thing. I told you that okay, if I'm keeping the dielectric substance, we will get a C value like this. A epsilon naught divided by d माइनस टी प्लस t बाई k, बहुत लंबा है, याद करना पड़ता है, राइट ना? ओके, वी गॉट. दिस इज व्हेन इट इज इन अ इंसुलेटिंग मीडियम. व्हाट इफ आई एम गोइंग टू प्लेस द कंडक्टिंग स्लैब? व्हाट हैपेंस? क्या होता है? करके दिखाओ ना सर, क्या होता है? हमको क्या पता है, राइट? सिंपल है गाइस. देखो, सेम टू कैपेसिटर प्लेट्स व्हिच आई एम गोइंग टू टेक. ये दोनों का पास में क्या है? ऑलरेडी चार्जेस है. चार्जेस आर ऑलरेडी रिसाइड्स ओवर द सरफेस ऑफ द प्लेट्स. ये दोनों का बीच में इलेक्ट्रिक फील्ड डेवलप होता है ड्यू टू दिस चार्जेस. एंड देन नाउ जस्ट इमेजिन दिस इज नॉट अ डाइलेक्ट्रिक वन, दिस इज कंडक्टिंग वन. क्या है? कंडक्टर है. कंडक्टर हो गया. ओके, उसका थिकनेस भी टी था, ये दोनों का बीच में डिस्टेंस भी डी था. नाउ टेल मी गाइस, व्हाट विल बी द नेट इलेक्ट्रिक फील्ड इनसाइड दिस कंडक्टर? ओके, नेट इलेक्ट्रिक फील्ड क्या हो सकता है? I will check now. How many will give the correct answer? Yes, Purnima, right. Amazing. Next. Good. Good, Yashaswini. That's right. Next. Ryan, well, bro. Good. मैंने बोल दिया था in electrostatics. Actually, if we are going to place any conductor means इसके अंदर इलेक्ट्रिक फील्ड भी नहीं होता है. इलेक्ट्रिक फील्ड का वैल्यू क्या होता है? इधर जीरो होता है, करेक्ट ना? बट वी नीड टू फाइंड आउट द कैपेसिटेंस अगेन. कैपेसिटेंस फाइंड आउट करना पड़ता है. कैपेसिटेंस के लिए फार्मूला क्या है? ये एप्सिलॉन नॉट बाय डी. डोंट फॉरगेट दिस वन. आई विल कॉल दिस इक्वेशन नंबर 1. बट ये पूरा का पूरा डी डिस्टेंस में इलेक्ट्रिक फील्ड इफेक्ट विल इज नॉट टेकिंग प्लेस बिकॉज इसके अंदर एक घुस के आ गया है. ओके, कंडक्टर. इसका थिकनेस भी थोड़ा है ना, उसको डिलीट करना पड़ता है. Right, what I'm saying? That's why here the net electric field means distance will become C is equal to A epsilon naught divided by total distance में thickness को छोड़ दो, then it will become D minus T. Okay, this is what the capacitance of the capacitor. Okay, when we are placing a conductor between our two parallel plates. Clear na? Yes, Yashaswini, right? Is that clear to everyone? Good. Good. Okay, if it is clear means guys, next क्या है देखता हूं एक बार. देखो, मैंने बोल दिया था उस समय ने. ओके, कैपेसिटर वैल्यू क्या आ गया था? डायरेक्टली प्रोपोर्शनल आ गया था, करेक्ट ना? रिमेनिंग होल क्वांटिटी इफ आई एम गोइंग टू सॉल्व मींस, मान लो दिस इज ओरिजिनल कैपेसिटर. Okay, then it will be increases by k times. Means k का एक value होता है. Okay, means guys, simple way I will tell you. This is a capacitor plate. Okay, ये दोनों को बीच में if you are going to introduce any dielectric substance, इसका पास एक k value होता है ना. k value मान लो 2 है. At this time capacitance value, now it's a new capacitor. I will give an example. मान लो this is capacitor plate, उसका capacitance है मान लो 2 farad है. Capacitance will be 2 farad. Highly impossible, right? But possible when we are giving a problems, right? Now I'm introducing in between these two a substance, dielectric substance. उसका k value है मान लो 2. K value है 2. Now I'm asking, now it become a new capacitance. सब कुछ capacitance change होता है, correct ना? What will be the new capacitance if I'm asking? Means just you have to take that one, k times the initial capacitance. K times the initial capacitance means k value है 2, initial capacitance कितना था? 2 farad. Means now how much हो गया? 4 farad हो गया. Means capacitance क्या हो रहा है? Increase हो रहा है, right? The value of capacitance will be increased by putting a dielectric slab between our two capacitor plates. Is that clear? Let me know. Is that clear, right? Good. One more concept and then we'll finish the class. डाइलेक्ट्रिक कांस्टेंट का वैल्यू क्या होता है, C by C नॉट होता है। कैपेसिटेंस और देखो इधर मैंने बोल दिया था न्यू C वैल्यू विल बी इक्वल्स टू K times the new old C value, initial C value. That took here C naught, I took as itself C. If I want to find out the K value in terms of C, then C take left hand side. Then it will become C dash by C value will be K. Means new capacitance or the old capacitance. It will be equals to K value. Clear now? With the dielectric slab. Okay, guys, I put one table here. Okay, I will send the notes in a group drive. Okay, try to download these notes and go through the values which I'm giving here. Tomorrow I will explain this one. Based on this one only, we are solving the numericals. Clear enough? This is all about today's class. This is all done about the today's class. Hope this class is understood to everyone. Kya? Abhi, I didn't get you. What I wrote wrong? Okay. Abhi, can you text me there? Where? Sorry, I understand where. Thank you, Gayan. Thank you so much, bro. Yes, good. Okay, tomorrow while coming up to today, what are the things we covered in our capacitors? No, try to take on short notes. Okay, means formula based one. Okay. Abhi, just wait for 2 minutes. I will unmute you. Okay, you can talk with me and tell me where I made a mistake. Yeah, tomorrow class पूरा न्यूमेरिकल्स है, खत्म हो गया सब कुछ. Okay, कहानी तो खत्म हो गया. Next war field. Tomorrow all of us we will be in a war field. Okay, then take care. Bye bye. Abhi, stay in a call. Stay in call. I will unmute you, bro. Yes. Bye bye. Bye, Yashaswini. हाँ, KYC. हाँ, unmute yourself once. Where any mistake I will take. Yeah, you can talk now. No problem. This one now. K is equal to. हाँ. देख. हाँ. Look at here. I will take. देखो इधर. C is the. Okay, it's a new capacitance. This is new capacitance, bro. I took here as an C dash. As itself, K is proportional to the capacitance. Okay, this is the whole capacitance, means original capacitance. I took here as its C. Right now, that's why here I write as an C dash is equal to KC. Here also same here. C is equal to K C naught, and K value if I want means I will take the C naught left hand side. Then it will become C by C naught is equal to K. Means this is new capacitance by original one. Here also it is new one. This is the original one. Correct, hey bro? It is correct. It's correct only. Cross check once. Okay. You can talk also. No need to worry about it. If you had doubt means you can directly talk. Okay. Bye bye.